Today we're looking at notes BB-1, Law of Sines when given three different letters, and Heron's formula. So before I point out this notice, I want you to look at the law of cosines. So here on the left, all these formulas will be used for determining side lengths. Okay, so today, if you don't have all three of your side lengths, you will use these first to get that third side length. So look at this, for example. If you want side length A, of course you'll have to square root both sides. But if you want side length A, you will need side length B and C as well as the angle A. Similarly, if you want side length B, you'll need A and C, the side lengths A and C, and you will need angle B. Okay, so notice that. Also notice, if you want to find a missing angle, so these formulas here are used for finding the missing angle, notice that all three of these formulas, you need all the sides first. This has side A, B, and C, this has A, B, and C, and this has A, B, and C. So to find angles, you first need all sides. Okay, so solve the triangle given side A is 8, side B is 3, and side C is 9. So obviously not to scale, but I do want to point out that when we get our answer, angle C should be the largest because it opposes the largest side. And then angle B should be our smallest because it opposes the smallest side. All right, so I've already started this. We do want angle A, B, and C. We don't have any of our angles. We do have all the side lengths. Okay, so to find angle A, we will be using the cosine A formula here for law of cosines. So cosine of A is equal to B squared plus C squared minus A squared all over 2 times B times C. Okay, so you plug this in the calculator using your alpha y equals key. So I'll show this once and then I won't show it again. So alpha y equals, you get 3 squared plus 9 squared minus 8 squared over 2 times 3 times 9. And if you use the alpha y equals key, it will shoot you a fraction first. And then you just need to hit math, arrow down for decimal, and hit enter. So 0.481, okay, when we put it on the paper. So when we put it on the paper, 0.481, right? So cosine of A equals 0.481. Of course, to find the angle A, you will cosine inverse. But when you plug this in the calculator, remember to get a more exact answer, we're going to do in the calculator cosine inverse, and we're going to copy that and hit enter. So we're not going to type in the rounded answer. We are going to copy the above. Okay, so then we get angle A equals 61. Remember, I did make sure it was in degree mode. You'll get 61.218 degrees. So 61.218 degrees. And again, I won't show the calculator again. If you need help with that, you can see me in class. So then we have angle A. We need to find angle B. So again, I'm just taking from the formula card, which hopefully you have in front of you. So cosine of B equals A squared, so 8 squared, plus C squared, 9 squared, minus B squared, all over 2AC, so 2AC. So cosine B, when you plug this in the calculator, you get 0.944. And then when you cosine inverse on each side, we find angle B is equal to, and remember to copy and paste, and not just plug in cosine inverse of 0.944. Okay, cosine inverse of 0.944. And then you get, when you copy paste, you get 19.188 degrees. All right, so lastly, you get lucky for angle C, because when we go to find angle C, all you have to use is your knowledge of a triangle. Triangles, angles add up to 180, so 180 minus 61.218 degrees minus 19.188 degrees, and you get 99.594 degrees. Okay, so on number 2, given angle A is 55 degrees, side B is 3 units, and side C is 10 units. I'm going to come over here and draw my triangle. So angle A here is 55 degrees based on what I was given. And then if this is B and C, then B is 3 and C is 10. Okay, so that's what was given. So remember what we talked about in the very beginning. We don't have all 3 sides. So first we need to find the side that is missing. So the side that is missing is A. So we'll have to use this formula first. Okay, so what do we want? We want angle B, we want angle C, but we also need side A, and we have to do side A first. So to find A, we're going to use the A squared equals formula. A squared equals B squared plus C squared, so 3 squared plus 10 squared minus 2BC cosine A. We got lucky because we do have angle A, cosine 55 degrees. So like I said earlier, of course you're going to have to square root each side, and hopefully you do remember that the square root of A squared is the absolute value of A, and when you plug this in the calculator and you round, when you plug that in, remember square root around it and then plug that in and you round, you get 8.636. To get rid of absolute value, you have plus or minus 8.636. And then of course, we are only going to use the positive version because this is a measurement. We're talking about, oops, help if I spelled measurement right. Getting ahead of myself. This is a measurement, so of course you'll use plus because a side length can't be negative in this case, our triangle here. Okay, so we're not talking about triangles in position in the unit circle where we could have negative. In this case, we're not going to have negative because we're talking of just triangles. So we have side A has to be 8.636 units, and then we can go to town finding, so find angle B. We'll use our law of cosines formula. So cosine of B equals, let me get it in front of my face, A squared, so we're going to use 8.636 squared plus C squared minus B squared all over cosine of B, 2AC, 2A, 8.636, and then C, 10. So all over that, plug that in the calculator, you get cosine B equals the 0.959. That's what you get. And then to find angle B, you say cosine inverse, and remember again, I'm saying it again, use the copy paste, don't just plug this in, use the copy paste. Okay, 0.959. And so then you get that the angle B is equal to 16.532 degrees. And that makes sense. It should be pretty small since that side length is small. Okay, so now I have B. So of course I can find angle C using my knowledge of triangles. So 180 degrees minus the given 55 degrees minus the 16.532 degrees equals 108.5 0.468 degrees. And again, that makes sense because side C is very, very long. So it should be the largest angle. Okay, so we're getting good hang of things. And now we're gonna move on to a picture, a figure from page 417 in the pre-cal book. It is a parallelogram, okay, and that was stated, parallelogram. Okay, so this is a parallelogram given in your book, page 417. I haven't drawn it exactly as it is in the book, but the sides and everything else are correct. So things I want you to remember from your knowledge of previous math courses of parallelograms. So if the parallelogram is slanted, C side, or not really side, but length of C will be greater than D. If the parallelogram is rectangle, then C will equal D, so these diagonals here will equal each other. All angles inside, so this angle plus this angle plus this angle plus this angle add up to 360. And the diagonals do not bisect the corners. That means this angle and this angle are not equal. Okay, they're not bisectors. So number 26 from your book gives A equals 25, B equals 35, and phi, that's called phi, is 120 degrees. So we're going to look at the triangles within the triangles to solve the rest of our unknowns. So what don't we know? We have A, we have B, we don't have D, we don't have C, and we don't have theta. Okay, so we want C equals, what D equals, and what theta equals. So find theta first. This is easy given phi. So find theta. Okay, we know all the angles add up to 360. So 360 degrees minus phi is 120. But this angle and this angle are both phi. They both match. So 120 degrees times 2, because there are 2 of these, equals 120 degrees. And then you divide that number by 2 because there are 2 thetas within this parallelogram, okay, and that gives you 60 degrees. So theta must be 60 degrees. Okay, so now to find C and D. So let's find C first. So to find C, we are actually going to be looking at this individual triangle here. So I'm going to color it so you can see. We're picking this orange triangle out of this picture. So I'm going to draw this, do my best, this, okay, where this angle here is our phi. That's 120 degrees. Phi equals, it's hard to see, but it's an equals in there, 120 degrees. And we know A, so this is A, equals 25 degree, or 25 units. And then we also know B, right, because these are equivalent, this one and this one. We know B is 35 units, okay? And what do we want? We want C. We want C. So to find, here I'm going to draw a squiggly, and I'm actually going to put this here. So to find C, we are going to use, we're going to call this C, and we are going to use our law of cosine. So it is C squared equals A squared, so 25 squared, plus B squared, 35 squared, minus 2, and then AB, so 25 times 35, cosine of C, cosine of 120 degrees. And again, like before, of course you'll square root both sides. I'm not going to show the progression of absolute value because you already know it's plus or minus, but you're only going to use the plus. So we're just going to say, plug this in, and we're going to come over here and say C equals, when you round, 52.202 units. Okay, so that's C. Now we're going to find D. Okay, find D. So to find D, I'm going to take, this is D, this whole length is D. So now I want you to think about the pink. Maybe wasn't the best color because it kind of overlaps the orange, but we're talking about this triangle here. Okay, so for this triangle here, we know a couple of things. So we know theta. It's confusing because there is no D, obviously, in our law of cosines. So we're going to relabel this. We know this is theta, and theta is 60. So this is 60 degrees. We will call this angle A. Okay, and we know that this measure here is A is 25, and we know that this measure here is 35, and what we want is quote unquote A, which is really actually D. Okay, so we'll use our law of cosines formula. So our law of cosines formula states that A squared, which is really D squared, so A squared equals, let me get my chart here, B squared, which is 35 squared, where is it? So A squared, B squared plus C squared, so 25 squared, doesn't really matter the order, minus 2, and then BC or CB, again, doesn't matter, 25, 35, okay, cosine of that A, so cosine of 60 degrees. And then of course you're going to square root, and you're going to get that quote unquote A, which is really D, is 31.225 units. Okay, so last problem, finally, using Heron's formula. So Heron's is for finding area of a non-right triangle. So given A equals 5, B equals 7, and C equals 10, because you need all sides, this is how Heron's works. So Heron's formula is right here. You first must get S to plug in S for the area. So S equals A plus B plus C, 5 plus 7 plus 10 over 2. So we have 22 over 2, which is equal to 11. Then the area equals the square root of, if you're looking at your formula card, S, which is 11, and then 11 minus A, S minus A, then S minus B, I'm saying B and writing B instead of writing 7, 11 minus 7, and then S, which is 11 minus C. Okay, square root that, plug it in your calculator, and you get the area of this triangle equals 16.248 units squared, right? That's it.